chapter 1 to 3, we were talking about different variables. So when you were calculating a standard deviation, means, all of them were a standard deviation or mean of a numerical variable. So what was variable? Variable was characteristic of individuals. Individuals were, for example, students in this class, and the variable, numerical variable, would be their exam score, correct? And then we were able to find the mean for exam score, standard deviation for the exam score, right? So we were able to actually draw a graph. For example, if we had a numerical variable, we could draw a histogram. We could explain that with a stem and leaf plot, correct? If our variable is like categorical, like gender, which is a categorical variable because we have different groups, right? We could use the bar graph, we could use pie chart, correct? So for one variable, we were able to draw a graph, correct? We were just focusing on just one single variable. Any variable, we could interpret that variable using graph. Now, from now on in this chapter, we are going to talk about more than one variable, the relations between variables. Like if we have an exam and there is some other, variables like how long they spend studying for the exam, something like this, which will be a variable, correct? And it will be a numerical variable because the study time will be time, right? Either hours or minutes, correct? So I can find the relation between these two variables, exam scores and the time that you spent on your, studying for the exam. So these two variables, I can find the relation between these two. So what is the relation? Means if I have such a question like how the time you spend for the studying for the exam will have effect on your exam score, for example. So I can answer this kind of questions. So this means the relation between these two variables, correct? How, for example, your age will have effect on your exam score. Maybe it has effect, correct? It can, easily you can find the relation because so elder people have more responsibilities, right? They have maybe children, they have lots of things, work, but younger student, maybe they don't work and their parents are taking care of, something, or yes, there are some situations, students also, younger students are working too. But mostly, you can say elderly students have maybe more responsibility in compared to younger students. So we can say maybe there's a relation between your exam score and your age, correct? Then there are different, variables. I can, bring more examples, but the main idea is just finding the relation between variables. So first I will explain the name of these variables, how it works and how we can separate them, like, and kind of label them. And then we will go through the graph because we are going to see a graph of relation between two variables. And this chapter 4 and 5, will be mostly based on relation of variables. Okay, so now let's talk about a study time and exam score, okay? So let's say we have a student's exam score as a variable, and then I have study time as the other variable, okay? So one of these variables between these two will have effect on the other variable. So I think after I explain and I talk, you should be able to know which variable, which one of these has effect on another one. Which one has effect on the other one?
Study time.
A study time will have effect on exam score, correct? So now you see the relation. Okay, so we have a variable, we call that y. Okay, we show that with y. This variable is response variable. Response variable. So response variable is the variable that is the focus of a study, goal of a study, kind of. Like your exam score is the focus of my study. I want to see how your exam scores is going to change with effect of different variables, right? Do you understand what I say? So I am going to focus on exam score to see how this exam score is going to increase or decrease depend on the amount of time you are studying, right? Do you understand that? So this is a response variable because this is the focus of our study or goal of our study. So another way to show the response variable is 1. And also there are different names for this response variable. I will write it down and then we will explain each of them and compare with the other variable that I'm going to, talk about. So response variable is also a dependent variable. Dependent variable. So when I say dependent variable, why? Because this exam score, change of exam score is dependent on other variable, right? The other variable was study time. So as you see, the response variable is depend on the other variable. The change of response variable will be depend on other variables. So that's why we call that dependent variable, because it will be always depend on other variable. The change of this variable will be dependent on the other variables. Then the other name for this is the predicted variable. So why we call this predicted variable? Because if I have some information now from your first exam, and I have, for example, some information about the study time, means the time you spend to study for this exam, in future, if I know how long you're going to study for the exam, I can easily predict your exam score based off all this knowledge. So that's why the response variable can be predicted. Can be predicted using other variable. So I can predict your exam score using like the study time for the future. So that's the reason we call this predicted variable. Okay, so these actually you can say these are 4. Y is the kind of notation, and then response variable, and then dependent variable, and then predicted variable. So these are all for Y, for response variable. And now as example you have the exam score, correct? In the study of finding relation between exam score and study time, exam score will be a response variable, will be dependent variable, will be what? Predicted variable, okay? So now, there is another variable in the study. We call that explanatory variable. We show that with X. Explanatory variable. So like we had different names for Y, we will have different names for X variable too. So this is the explanatory variable and also independent variable. It's not dependent on response variable. There are many other variables actually can have effect on the exam score, and this is one of those many variables. And we can easily change it and obviously change of exam score will not have effect on your study time, correct? Because the study time happens before your exam score, right? So change of exam score will not change the past, like how long you were studying for the exam. So that's why it is independent variable. And then the other name, predictor. Why? Because we use this information to predict exam score, right? So it will be predictor, correct? So predictor. Okay. So now we know all these names, and I want to talk about this a little bit because there is sometimes a confusion because some people believe that we cannot call explanatory variables and independent variable. Yes, this is not dependent on response variable, but sometimes it can be dependent on some other explanatory variables. Okay?
Yes.
So, for example, your study time may be exactly, correct? So maybe there is other explanatory variable also can have kind of, effect on this. And your study time will be depend on your work time also, correct? So I can even have a study like that. Find the effect of your work time and the study time, both of them, on the exam score, correct? So now easily you can see I can have either one explanatory variable in the study, or I can have many, more than, one, correct? But mainly, if we are talking about response variable, we are just talking about one response variable in each study and in each hypothesis. Later, in future chapter, we will talk about hypothesis too. So now sometimes maybe you see that, there is a doubt about explanatory variable being independent. Now you know why. Because maybe there are other variables that, have a relation with explanatory and they are dependent on each other. And those variables will be explanatory variable. But obviously, this variable, explanatory variable, is not dependent on exam score or response variable. Do you have any questions so far? Sure? Okay, so now I want to show you actually before that maybe we can talk about, let's talk about drinking beer and level of alcohol. Okay, so let's say we have a study here. How does drinking beer affect the level of alcohol in your blood? So we have two variables here, right? What are those two variables?
Beer and the level of alcohol.
So two of them, right? One is the amount of beer you're drinking, either glass, mugs, or beer. Beer is not shot. I know this one. Beer is not shot. Yeah, you drink.
Their college dates.
What is that? Okay, so drinking beer, either like mug or what is that? This big what you call that?
Pitcher.
Pint?
Yeah, pitcher.
Pitcher.
I was like, are you gonna post this on YouTube?
Yeah.
Really?
You're like to ban me or what?
They're gonna be like, the teacher drinks beer? Like, what?
No, I didn't say I drink.
She's 21.
I said I know these kind of things. Did I
Well, how would
say
you
I
know these kind of things if you don't drink?
We are living in America, right? Okay.
Sure.
Okay, I have to cut this part. Okay, so let's go back to the study. So, amount of beer you are drinking and level of alcohol in blood, right? So these are two variables. So, which one have effect on the other one,
Amount of beer.
The beer has
The beer.
Yeah, beer's have effect on alcohol.
right? So amount of beer has effect on level of alcohol. Like the study time had effect on exam score, right? The study time was explanatory variable, had effect on response variable, right? So what is the response variable here? Alcohol level, right? Because that's the focus of a study. We want to see how this level of alcohol in blood will change, correct? Depend on the amount of beer. So amount of beer will be explanatory variable, right? So this one is explanatory variable. This one is yes. So now I have more variables. We want to find the relation between them, and then I will give you a kind of some sentences will help you to find explanatory variable and response variable, because in future, in these two chapters 4 and 5, you have to know all of this, and you have to know how to find the explanatory variable, how to find the response variable. Without knowing that, you cannot solve any problem, any question. You should know first which variable is response, which variable is explanatory. So how we can know? So we'll start with some example, and then I will give you a kind of sentences. So let's say chemotherapy dose of drug. Actually, this one is length of chemotherapy. Then age, gender, all of these are some variables. And then there is the other variable here. Survival time for cancer patient. Okay, so there are some variables, and I can say these variables have effect on survival time, right? So what is the response variable in this study? Right? Survival time is response variable. Why? And then this can be explanatory variable. Let's say the first explanatory variable. This can be another explanatory variable, correct? And this can be another explanatory variable. This can be another explanatory variable, right? And then all of them have effect on survival time. So this is a kind of example and a study. And then I can say let's say high calorie is that correct? Food, and let's say body fat percentage. So can you tell me which one has effect on other one?
The high power food has effect on the body.
Correct?
Yeah.
Do you see that? So this one will have effect on this one. So what is this one? What we call this variable? Explanatory variable. So the first sentence now I can write down and will help you to find explanatory and response variable is this. Explanatory variable will have effect on response variable. So if you have this kind of format in a sentence or a study, you know which one is explanatory, which one is response variable. So in here, response variable is body fat percentage, correct? So now let's write down the first sentence which help you to find the x and y. So x, which is explanatory variable, has effect on y. So this is the first sentence you can use to compare with any question or study to figure out which variable is explanatory, which variable is response variable. And then second will be like this. X cause a change in y variable. Maybe you see a sentence like this. There is one variable here, cause a change on other variable. So this variable will be explanatory, another will be the response, right? And then x was a predictor, right? X is predictor. You may see something like this. A variable predicts the other variable, right? Because x is a predictor, right? So x can predict the y variable. So I can change this to the other form. I can say y. How I can change the grammar? Exactly. No, using predict.
Oh.
It's predicted by.
Predicted by, right? Is predicted by x. So these are all the sentences you can use to find the explanatory, to find the response variable. So, do you have any questions? Is there any question? So you should like either memorize this or write down somewhere for your like exam. You can write this down in a formula card. So it will be easier for you to use it because you definitely need to remember all of this. So now, are you done? Okay. So any question? So the next topic here is the graph. This graph shows the relation between two variables. Like explanatory variable with a response variable, right? And then also it can show the relation between two explanatory variables too, like the amount of time you spend studying for the exam and the work time. These two also. So any two variables, but you should keep in mind these two variables have to be numerical. So when I say study time, we know that is numerical, right? There's a unit of measurement for the time. When we say work time, also it's a numerical. When we say exam score, that is a numerical. So if you are using a scatter plot, which is a graph showing relation between two variables, you should make sure both of variables are numerical. So you cannot find a relation between, for example, gender and the exam score in this graph. Why? Because gender is categorical, right? So keep that in mind, that is important. So now, there are some points here. On x-axis, we see measurement. On y-axis, we see some measurement. Why? Because numerical variable will have measure, right? They are based on numbers. So it says percent of graduate taking the SAT exam, and the other variable is state mean SAT mathematics score. So there are two numerical variables, right? So which one has effect on the other one?
And the mean SAT mathematics score. Oh, percent of graduates taking the SAT.
Percent of graduate taking SAT will be the response.
No, it has an effect on the mean.
It has an effect on the this one, right?
I just said because it's x-axis.
Exactly. Actually, that is a good point. I will talk about that too.
It's x-axis, so it's explanatory.
Yeah. So sometimes you have a doubt like this, correct? If you are talking about explanatory variable and response variable, and the study knows that there is a response variable, there is an explanatory variable. Explanatory variable, because it is x, is going on x-axis. Response variable, because it's y, goes on y-axis. If you know we have response variable and explanatory variable. But let's say we don't know, and maybe we are dealing with two explanatory variables. So it doesn't matter. But if we know we are dealing with response and explanatory, we know where to put them, right? Okay. So now we know this person of graduate taking the SAT will have an effect on mean of SAT in a state. So each of these points will have x, will have y, right? These are ordered pairs, and we'll have x coordinate, y coordinate. So obviously x coordinate is the percent of graduate taking SAT, and then y coordinate will be the state mean SAT mathematics score, right? So each of these points consider as an individual, because each individual will have x and y. So let's talk about easier example, then we'll go back to this. Each student in this class will have exam score and a study time, right? Is that correct? So exam score was the y, study time was the x variable, correct? So we have a kind of order pair for each individual. If these points on the graph shows each individual, so if I have almost 30 students in this class and I'm going to draw a scatter plot of the relation between exam score and the study time, how many points I should have on the scatter plot? 30, correct? The number of individuals, because each individual will have x and y variable, right? So now, our responsibility is not drawing this kind of graph, but we should know how to interpret this kind of graph. This is a scatter plot showing relation between two numerical variables, right? There are three different ways to explain this graph or interpret this graph. Means explain the relation between two variables. One is the form of scatter plot. Form of a scatter plot. Then it will be direction of the scatter plot. And so I will explain all of them in detail, write it down all of them. And then we should see how strong is the relation based on a scatter plot, or how weak is the relation. So let me write down the first things about a scatter plot. One, and the most important that I repeated 2-3 times, is a scatter plot shows the relation between two numerical variables, correct? Then I said these two variables can be response and explanatory, or these two variables can be two explanatories, right? Then I said, if we know which variable is response, this goes on y-axis, correct? This goes on if we know which variable is explanatory, it goes on x-axis. Then I said each point on this graph shows one individual, right? This individual will have two information, like we'll have x and y as information. So now this is the most important part, how to interpret the scatter plot. To interpret the scatter plot, we will talk about the form of relation we will talk about the direction of relation. We will talk about the strengths of relation. Form of relation can be linear or curvature, or there are different forms, but we are not going to talk about different forms. And also beside that, in this class we are just going to concentrate on linear form. The linear form, whenever you can pass a linear line through all these points, that relation is linear. Like here, if you want to draw a line, the line will pass through all the points in this form, right? The line will be a straight line. In compared to, for example, a scatter plot like this, of course you can see this form is kind of curved, right? Because you cannot pass a straight line through all the points. And there is a form or line, curved line, like this, passing through all the points. So this is a curvature form. Then curvature form can be like this. Correct? So these two are examples of curvature form. And then this one will be example of a linear form, because you can pass a line through the points. And let's say this is the easier example of linear form, because you can pass a line, a straight line, through all the points, okay? And then we may have something like this. So there's a difference between these two. But at least if I ask you what is the form, you can say form is linear for both of them, correct? Because you are passing a straight line through all the points. Do you have any question about this? So if question asks you what is the form of a scatter plot, you will say either linear or curvature. That will be the only answer, either curvature or linear. Do you have any question? Okay, so now direction of scatter plot. So let's focus on linear form, and my example will be based on linear form, which is easier to understand, okay? Direction of a scatter plot can be either positively associated or negatively associated. Positively associated and negatively association will be related to slope of that line passing through all the points. So if you think, maybe you can find a relation. If the slope of line, what slope we have here? Positive or negative? Positive. So if a slope of a line is positive, the direction will be positive association. So do you see the relation? So the slope is positive, we have a positive association. So in parentheses, I will write down m, slope is m, right? Greater than 0 means positive. Correct? Do you remember this from your math?
Yes.
So this is a positive slope. So what is the slope of negative association? Negative. Correct? Or negative association. So the slope n is negative. There is a lot more about direction of a scatter plot. We can talk about positive association, about negative association. Okay? So let me talk about this kind of now before moving forward. So let's say in that graph we have with a positive slope, we have exam score on this axis because exam score was y variable, right? And then what we had on x-axis, study time, right? So you know that on x-axis or y-axis, it starts from origin 0, increases to this side, right? So means the study time is going to increase to this. Exam score starts from 0, increases. Okay? So if there is a student here, let's say this individual is a student with this much exam score on x-axis, okay? And the study time on the x-axis, and this much exam score on the y-axis. Do you understand this? So there's a point here, and then I said it will have x, it will be a y, and there is an individual. And then there is another point here. Another student will have this much study time and this much exam score. So, for this student here, we had a lower study time. And then lower what? Score, okay? So compared with the other individual in here, which had a higher study time and higher exams. Is that correct? Do you understand this? So as you see, if the study time increases, exam score will increase, right? If the study time decreases, exam score will decrease. So this is a definition of positive association. One variable increases, the other variable also increases. Yes?
What do you have an outlier? Like you have somebody who studied for like 10 minutes but got...
Oh, there is a more kind of explanation when we have an outlier. And the next chapter I will explain the effect of outlier on the line and on our scatter plot, on our relation, everything. We will talk about that. Yes, that will have effect, of course. No, but the pattern is always the same. When we have a positive slope, when we have a positive association, as one variable increases, the other variable will also increase. So, can you give me examples of two variables which will have a positive association? In parentheses, one variable increases, another variable also will increase.
Oh, practice time and performance.
Performance on exam.
Yeah, so like, I was thinking something track, it's like, there's runners. They always,
Yes, exactly.
They practice and they practice. The more you practice, the faster.
Exactly. Is that right? So the practice time for athlete, and they will have a better performance, of course. So that will be a positive association, right? More example.
Let's say amount of pollen in the air and how many individuals got sick.
Exactly. So the amount of air pollution has effect on people's sickness, right? We will have an example like that. You will see, we will solve a problem like that. Air pollution will have effect on hospital emergency call. We will have something like that. You will see. What else? In real life, what else example comes to your mind as a positive association? What? You don't have any example? Really?
How many cold days in the sales and coffee or hot drinks?
Good example. The amount of drinking hot beer. Oh, sorry.
Hot beer.
Extra
Hot
hot beer.
sake.
Nice cold day.
No, because when you go to sleep, you see people are drinking this. What is that in?
Malt.
Esquibase and No, that part, top part, they are always drinking. That's
Malaysia?
I don't. Yeah, they have bar. They have bar. People drink because that warms them up, something like that. Yeah, hot chocolate. Actually, I always drink hot chocolate there. I promise you, no.
Hot
Do we
chocolate.
even have a hot beer?
Disgusting.
There's warm stuff.
No.
Disgusting.
Okay, so hot chocolate and yeah, cold weather. Okay, so tell me, what else?
Snow days and car accidents.
Snow days and cars. See how many examples she has? Give me some example. It's easy. You don't remember anything?
Stress levels on finals.
And effect on? We are searching for a positive association, right?
Cortisol.
Huh?
Cortisol.
What is that?
That's stress hormone.
Oh. See, statistics is everywhere. Chemistry. Right? Okay, so now, so if you think about this, you will have more examples. I know, I mean, later you can think about this and you will see many examples that in real life will have a positive association. So now I will talk about negative association. That would be actually so difficult for you to find it. If finding positive association was difficult, that would be more difficult. So look at this. So, sleeping time before exam. So there are some students they sleep a lot and so they don't study, right? That would have a negative impact on your exam. Am I right? Yeah, you're sleeping all the day and you forget about your exam and then you don't study, right?
Or you can sleep very little. And
That had a bad effect on exam probably. But now let's talk about the sleeping time before exam. Before exam, which has which is an explanatory variable, and then your exam score. So there is one individual here before exam. Okay, we start with 6 hours of sleep because you need 6 hours of sleep, right? So this individual will sleep just 6 hours and had more time to study and will get a good exam score, right? Less sleeping time. Let's say start from 5 to 6 hours, something like this, and go to like 12 hours.
So
Oh my
wouldn't
God.
this be a
Mad.
curve?
Huh?
Should this be
Let's
a
say it's
curve?
linear. Let's say it's linear, okay? Because I told you it's difficult to have a two variable which has a negative association. Well, let's see how this works. So, slept, almost kind of minimum amount, and then get a higher score, right? And then there is another individual who sleeps 12 hours and actually is late to exam, maybe, and then we'll get awful score. Do you see that? So this is a negative association. Means one variable increases, another variable will decrease. Correct? Do you see that? So now give me an example of two variables. Yes.
So the price of the gas and the amount people fill in their car.
The amount people. So which one increases?
So if the gas price increases, fewer people are refilling their car.
More?
fewer.
Fewer. Exactly. Correct. Right? So price of gas will increase and then we have less customer. Right? Anything else? People who have an economic background will have lots of examples. See, I told you this is difficult. But actually, I had my best examples from my students. So I'm using those examples. So students told me, Of course, you're a student, young, and always on the phone. You know, they told me if you talk on your phone or work on your phone more, what happens? Battery life is decreasing, right? So this is a negative association. Anything else? That was a good example, huh? My student had that example. So bring some example to me. I'm going to use for future. Tell me.
So as you get older, the closer you are to death.
Oh my God! Yeah, that is true. But let's go think about it.
The more Netflix shows you watch at night, the less sleep you have.
Bad exam score you will have, right? Yeah, that was good. More Netflix, less sleeping time.
Yeah.
You even don't think about the study exam.
I didn't study for this. I studied.
Okay. Anything else? I have one more example. Actually, I'm waiting to see if you think about that. Huh? What? Give me an example.
Oh,
Negative association. So one variable increases, another will decrease.
The more you use your pen, the less ink.
Good. Yeah. That was good. More you are using your pen, less ink, right?
more businesses, less density of population. More building businesses, like in a city, urban, less density of population. If there's more buildings or more people living in a place, if there's less, there's going to be less people. In general.
I just think she wants one that is one goes more and then one goes less. So they're opposite.
Yeah, they are opposite. So the more dense the businesses is in a place, the more people are, it goes down. The more people are likely going to be living in that place. And the less density of businesses there are in a place, there's going to be less people wanting to live in that place. So
oh, living, yeah. So, yeah, like if you have more school around, I mean, it happens in my country. When there are more school around, there are less, kind of people wants to live around that school because of all the noise, everything. Is that correct? Like business, also too much business, and they don't want to be around that. Do you mean
it
that?
can go either way. If there's more, like for example, there's more grocery stores, there's more resources in a place, then likely there's going to be more people.
More
in
people
that place.
around, yeah.
Yes. If there's less businesses in that place, there's most likely going to be less people in that place. So, for example, like LA has more stuff in it, more people. Gallup has less stuff in it, less people.
Oh.
Yeah, that's what I'm saying. That's a positive.
That's a positive
yeah,
association.
she was trying to look for one.
Now I understand what you say, but I think that's a positive association. One is increasing,
and
another is.
Yeah, I was saying it can go either way.
Yeah, it
So
can.
it can go.
So both increases together and decreases together, right? That's an example of positive association.
Yeah.
Yeah,
You
now
want-
I understand.
You wanted one of negative, but one was.
Yeah, we want negative association. So, yes.
More taxes, less personal income.
Exactly. Yeah, that's sad about America. And actually in Europe it's
Everyone's real
awful.
sad in
It's
class.
even worse.
Like 40%.
Yeah.
You guys good?
It's really awful.
I'm not good, honestly.
More weight you put on, less clothes will fit.
Oh! Yeah, that's actually a big one. Yes, that's good.
More government regulations.
Say
less
something
businesses.
Less what?
Businesses.
Think
Job
of
growth.
something happy.
That is true too. So I said mostly in economic, if you understand economic, you will have lots of questions, correct?
Oh, if you raise the alcohol purchase, like the age.
We were done with amount of alcohol we
No,
talked about.
if you raise the alcohol purchase age, then less people are going to buy.
Yes, you are right.
That's more.
You are right.
Yeah, 'cause if you
So,
raise the age, then
but for all of this, you see, there is always some other factors will have effect, correct? We are just talking generally. But if you want to be really more precise, we can see it's not maybe always 100% true because there are always other explanatory variables will have effect, right? And then easier example I can say, when you drive more, you are getting closer to your destination, right? More mileage, less destination. That was also one of the
She
examples.
said for happy stuff, more
Or the more you
vacation days,
drive, the
less
more
stress.
miles.
Yeah, less stress, exactly. That is true too. So now I think you understood the concept of negative and positive association, right? So what time is it?
42.
Oh, I still have 2 minutes.
What could you possibly
Strength.
Okay, strengths. Let me just talk about this for maybe 1-2 minutes, and then again we will go back through everything next time. Okay. So either the relation is strong or weak. So how do you explain this? Let's say here we have all these points around the lines, close to the lines, and then here we have lots of points everywhere, scattered everywhere, and it's not close together. So whenever these points on a scatter plot is around the line, close together, on top of line, like this, we have a stronger relationship, okay? When the points are scattered everywhere and they are not closer to line, we have a weak relationship. So you see that doesn't matter what is the direction of a scatter plot, we still can talk about a strength, right? Here direction was positive. I have a strong relation, but I could have a positive direction and weak relation, right? So it doesn't matter. So mostly we are going to talk about linear relation in this class, okay? So you should know how to interpret a scatter plot using these three form, direction, and strength. And then next time, again, I will go back to the direction. We will talk about that more. And then also later we will see a measure like a standard deviation, like mean, which can explain and make everything more precise for us, rather than just looking at the graph and say, oh, this is big, this is strong. So it's not reasonable just to look at the graph and judge, right? So we always should have a measure. Next time we will talk about that. Do you have any questions? Okay, so we'll see you. Today's Wednesday? Okay, we'll see you on Monday. Take care.